There is a strange paradox that almost no one ever thinks about. More than half a century ago, humans walked on the moon. We have photographed a black hole tens of millions of light years away, sent robots across the surface of Mars, and even begun speaking seriously about building cities on other planets. And yet, we may understand the surface of Mars better than the world beneath our own feet. From Earth's surface to its core is about 6,370 kilometers. But throughout all of human history, we have drilled only a little more than 12 kilometers into the planet. If Earth were the size of an apple, everything we have ever drilled would be nothing more than a thin scratch on its skin. Below us lies a hidden world humanity has barely touched, a world of crushing pressure, ancient rock, trapped water, extreme heat, and geological memories older than life itself. The mystery was never far away. It was always beneath us. And now, China wants to go deeper. In the brutal Taklamakan Desert of northwestern China, where summer heat becomes almost unbearable, and sandstorms can swallow the horizon, a massive drilling rig stands in a nearly lifeless landscape. Its mission is to create one of the deepest artificial holes in human history. The project is called Shenditake-1. Its planned depth, 11,100 meters. But the most astonishing part is not just the number. It is how hard each meter becomes. The drilling took more than 580 days, and more than half of that time, about 300 days, was spent drilling only the deepest 910 meters. In other words, the deeper it went, the more every single meter felt like a battle against the planet itself. The borehole passed through 12 geological layers and reached rocks more than 500 million years old. Rocks that existed long before the dinosaurs and before much of complex life on Earth. More than 2,000 tons of drilling equipment and steel pipes were forced through those ancient layers. To make this possible, China developed the world's first automated 12,000-meter drilling rig, along with advanced ultra-deep logging tools that allow scientists to monitor a world no human eye can ever see. Chinese engineers compared the challenge to driving a heavy truck across two thin steel cables. And when you look at how slowly the final meters were drilled, that comparison no longer sounds exaggerated. But this is not simply a story about drilling a deeper hole. Because while humanity has spent centuries looking upward, dreaming of the stars, one of the greatest mysteries in existence has been beneath our feet all along. And every time we drill deeper into the planet, Earth reminds us of the same uncomfortable truth. We know far less about our own world than we like to believe. Humanity barely knows what lies beneath Earth. But why is the world beneath us still so difficult to understand? The answer is simple. Earth does not let us look inside. We cannot open the planet. We cannot send cameras into the mantle, and no machine has ever reached the core. Almost everything we know about Earth's deep interior comes from indirect evidence. Seismic waves, mathematical models, and signals passing through the planet. The deepest artificial hole ever created reached only about 0.2% of the distance to Earth's center. That means almost the entire inside of our planet remains beyond direct human experience. So scientists must listen to Earth from the outside. When earthquakes happen, they send vibrations through the planet. These waves bend, slow down, speed up, or sometimes disappear entirely, depending on the material they pass through. By studying these changes, geologists build models of Earth's hidden structure. That is how we know Earth has a crust, a mantle, a liquid outer core, and a solid inner core. But models are not the same as reality. They are powerful, but they are still interpretations. It is like trying to understand the inside of a watermelon without cutting it open. You can tap it, weigh it, and listen to the sound it makes. But until you cut into it, there will always be uncertainty. That is why deep drilling matters. Every meter drilled downward is one of the only ways humanity can physically touch a world that normally exists only in scientific models. A rock pulled from 10 kilometers underground is not just a piece of stone. It may contain ancient minerals, hidden water, chemical traces of prehistoric tectonic activity, and evidence of lost oceans or buried mountain ranges. In a way, deep drilling is not just going downward. It is traveling backward through time. Each layer of rock is a page from Earth's memory. But the deeper humans go, the more the planet refuses to behave as expected. Sometimes, temperatures are far higher than predicted. Sometimes, water appears where rock was supposed to be dry. And sometimes, The crust turns out to be more fractured and mysterious than anyone imagined. That is what makes ultra-deep drilling so important. It does not only confirm what we know, it exposes the limits of what we thought we knew. And long before China launched Shendataki-1, another superpower tried to open this hidden world, creating a hole so deep that it later became surrounded by myths, conspiracy theories, and stories about the sounds of hell. The Soviet hole that changed geology. Long before China launched Shendataki-1, another superpower tried to reach the depths of Earth. During the Cold War, the United States and the Soviet Union competed not only in space, but also underground. In 1961, America launched Project Mohole, an attempt to drill through the ocean floor and reach Earth's mantle. The idea was promising, but the project collapsed under political conflicts and rising costs. The Soviet Union decided to go further. In 1970, Soviet scientists began drilling the Kola Superdeep Borehole on the Kola Peninsula, near the border of Norway. Their goal was simple but ambitious: drill deeper than anyone in history and uncover what truly exists beneath Earth's crust. And at first, everything went according to plan. By the early 1980s, Kola had already broken world records, eventually reaching 12,262 meters, still the deepest artificial point ever created by humanity. But the deeper the drill went, the stranger the discoveries became. Scientists expected to hit a basalt layer several kilometers underground. Instead, the drill kept cutting through fractured granite. Temperatures were also far higher than predicted, reaching nearly 180 degrees Celsius. Then came the biggest surprise: water. At depths where rock was supposed to be completely solid and dry, scientists discovered superheated water trapped deep inside the crust. The finding challenged decades of geological theories. Soon, Kola became surrounded by myths and conspiracy theories. Rumors spread that Soviet scientists had recorded terrifying sounds from hell deep underground. The story was fake, but it transformed the borehole into one of the most mysterious scientific projects of the 20th century. But Kola did not prove that Earth was supernatural. It proved something more disturbing. Even our best models could fail just a few kilometers beneath the surface. Yet the real lesson of Kola was even more unsettling. Every time humans drill deeper into Earth, the planet reveals something unexpected and proves how little we truly understand about the world beneath us. China enters the race beneath Earth. But unlike Kola, Shendataki-1 was not born from a Cold War race for scientific prestige. It belongs to a new age, an age of energy security, automated drilling, artificial intelligence, and strategic competition. When China began drilling in the Taklamakan Desert on May 30th, 2023, it was not simply trying to break a depth record. It was entering one of the most important races of the 21st century, the race to control what lies deep beneath the planet's surface. And the battlefield could not have looked more unforgiving. In the middle of the Taklamakan Desert, a place of burning heat, violent sandstorms, and almost lifeless silence, a massive drilling rig began forcing steel into the earth. Above it was endless sand. Below it was a hidden world of pressure, heat, ancient rock, and darkness. The location was not accidental. The Taklamakan Desert sits inside the Tarim Basin, one of China's most important energy regions. Beneath its sand lie vast ultra-deep oil and natural gas reserves, resources buried so far underground that ordinary drilling technology is no longer enough. For China, this is not just economics, it is national security. That is why Shendataki-1 is different from the Soviet Kola project. Kola was a scientific symbol. Shendataki-1 is also a strategic tool. At more than 10 kilometers underground, heat can rise above 200 degrees Celsius. Pressure becomes extreme. Electronics can fail, steel can weaken, and a small mistake can trap kilometers of drilling pipe beneath the surface forever. At that depth, the danger is invisible, but constant. The drill cuts through fractured stone, hidden fluids, and unstable formations that can shift without warning. Every meter downward becomes slower, riskier, and more expensive. This is where modern technology changes the story. Shendataki-1 relies on automated drilling systems, advanced sensors, and ultra-deep logging tools designed to monitor a hidden world in real time. Engineers must constantly read the underground environment, temperature, pressure, rock behavior, and the stability of the borehole itself. In other words, this is no longer just drilling. It is deep earth navigation. And in this new race, depth is not only a scientific achievement, it is a strategic advantage. The deeper a nation can drill, the closer it gets to hidden energy, underground heat, geological data, and resources that could shape the future economy. But the deeper the drill goes, the more the mission begins to feel like something stranger than resource exploration. It is a probe sent into a place older than civilization itself. If Kola showed how mysterious the deep earth could be, Shenditake 1 shows something else. In the modern world, whoever can reach deeper may gain access not only to knowledge, but to energy, resources, and power. More than science, a question about the future. At first glance, ultra-deep drilling looks like a scientific breakthrough. It gives scientists access to ancient rocks, hidden fluids, underground heat, and geological records that have been locked away for hundreds of millions of years. A rock pulled from 10 kilometers underground is not just a piece of stone. It can preserve traces of lost oceans, ancient tectonic collisions, chemical changes, and pressures no human body could survive. In that sense, deep drilling is like opening a time capsule buried inside the planet itself. But science is only one side of the story. The deeper humans can drill, the closer they get to resources that may shape the future economy: oil, natural gas, rare minerals, underground water, and geothermal energy. And that is where the story becomes more complicated. To some, ultra-deep drilling is a doorway to the future: cleaner geothermal energy, better earthquake monitoring, and a deeper understanding of the planet. To others, it is also a warning sign, a sign that humanity may continue digging for fossil fuels even in the most extreme places on Earth. This is the conflict at the heart of projects like Shenditake 1. Humanity says it wants knowledge, but deep beneath the surface, the drill is still searching for fuel. Or because we are still searching for more fuel to burn. Are these boreholes tools of science? Or are they part of a new race for hidden resources and strategic power? The answer may be both. And that is what makes ultra-deep drilling so important and so unsettling. Personally, I think projects like Shenditake 1 reveal both the brilliance and the obsession of our species. Even after reaching the moon, humanity is still unable to stop digging deeper into the earth beneath its feet. They are powerful tools. And like all powerful tools, their meaning depends on how humanity chooses to use them. If ultra-deep drilling helps us unlock geothermal energy, monitor tectonic stress, and understand earthquakes better, it could become one of the most important scientific tools of the future. But if it becomes only another way to reach deeper oil and gas reserves, then it may also reveal something uncomfortable about us. That even when we speak about the future, we are still digging for the past. Perhaps the real question is not whether humans can drill deeper. The real question is what we are hoping to find when we get there. Because beneath the surface, Earth holds more than energy and minerals. It holds knowledge, it holds danger, and it holds a mirror to human ambition. The final frontier beneath our feet. Today, the Kola Superdeep Borehole sits abandoned in northern Russia, sealed beneath a simple metal cap. The towers are gone, the buildings are decaying. But beneath that quiet surface remains one of the deepest marks humanity has ever made on Earth. And now, in the deserts of China, that old dream has returned, not as a Cold War contest, not as a myth about the sounds of hell, but as a new kind of race, a race for knowledge, energy, resources, and the hidden future beneath our feet. To me, what makes ultra-deep drilling so fascinating is not only how far it goes, it is what it reveals about us. Humanity has always wanted to cross boundaries. We crossed oceans. We climbed mountains. We reached the moon. We sent machines to Mars. We looked into the ancient light of distant galaxies. And yet, the world directly beneath us remains almost untouched. The deeper we drill, the more Earth stops feeling like familiar ground and begins to feel like an alien world beneath our own civilization. A world of ancient stone, hidden water, crushing darkness, and memories older than imagination. They remind us that exploration does not always mean going upward into space. Sometimes the unknown is below us. Sometimes the greatest mystery is not on another planet, but inside the one we already call home. And perhaps this is the most humbling part of the story. For all our technology, for all our confidence, Earth is still not fully known to us. Every ultra-deep borehole is like a narrow question sent into the darkness, and every answer that comes back seems to say the same thing. We have only scratched the surface. Perhaps the next great discovery in human history will not come from the stars above us, but from the darkness below.